Hello everyone, welcome to the learning field. In this video, we are going to solve the integral equations of the CSIR-NET December 2023 paper. Okay, so there are total 3 questions comes in the paper. One is of 3 marks and 2 are of 4.75 marks. Okay, so let's solve the problem. I think the solutions are very easy of these problems. Okay, so this is a 3 marks problems of CSIR-NET December 2023. It says that the value of lambda for which the integral equation has a non-zero solution. So the given integral equation, if we write, this is equal to yx is equal to lambda integration 0 to 1 x square e to the power x plus t into yt dt. So we write, तो लिख सकते हैं क्या इसको, लैम्डा एक्स स्क्वायर ए टू द पावर एक्स इंटू 0 to 1 and e to the power t y t dt. Now if we want to solve this problem, then this quantity we take c. So this is equal to, if we write lambda x square e to the power x into c, okay, y x is equal to, and c equal to integration 0 to 1 e to the power t y t and dt. Now this is the value of yx. Now if we put, this implies yt equal to lambda t square and e to the power t into c. Now we put the value of y to this equation, integration 0 to 1 e to the power t into yt means lambda t square e to the power t into c. So this is equal to c lambda outside the integration 0 to 1 t square e to the power 2t dt. Now we have to integrate this thing. For this we use the shortcut key, the di method. Okay, so the di method, so I write, I think you all know the di method. So this is t square, then the differentiation is 2t, then 2, then 0, and the integration the term is e to the power 2t, then integration of this e to the power 2t by 2, then again integration e to the power 2t by 4, then again integration e to the power 2t by 8. Now we multiply this and this with plus, minus and plus sign. Okay, so that means the integration is c lambda into t square e to the power 2t by 2 plus 2t e to the power 2t by 4 minus, sorry, this is minus, this is not plus, minus, and then plus of 2 e to the power 2t by 8, and the limit of the integration is 0 to 1. Okay, so this is equal to c lambda into, if we put the integration, this is 0 in the lower limit, so only upper limit is present, e to the power 2 by 2 minus 2 e to the power, and 2 goes to 2. So this is also e to the power 2t by 2 and plus this is 4. So e to the power 2, not t, e to the power only 2, e to the power 2 by 4 minus, here only the lower limit present. Okay, that is 1 by 4. So this implies, if we take c common from both sides, so this is 1 minus lambda into, this term goes to e square minus 1 by 4. These two term goes to cancel out, 1 minus lambda into e square minus 1 by 4, and this is equal to complete 0. Now if c equal to 0, then we get trivial solution, and we have to find the non-trivial solution, then c must be non-zero. Okay, then 1 minus lambda into e square minus 1 by 4, this term is equal to 0. That means lambda equal to 4 by e square minus 1. This is our answer. So option C is the correct answer for this problem. Next question. This is a question 4.75 marks question. Okay, the question says that consider the freedom integral equation yx minus this. So if we write this integral equation, then we can write yx equal to fx plus 3 integration 0 to 1 tx yt into dt. Okay, now if we compare this integration lambda into 0 to 1, then we easily see that lambda value is here 3. Now read the question, where fx is a continuous function defined on the interval 0 1, which of the following choices of fx have properly that about integral equation admits at least one solution. Now if we want to proceed the solution procedure, then if we write this is equal to fx plus 3x integration 0 to 1 pyt dt, and if we take this is c, then this is equal to fx plus 3xc, this is yx equal to, okay, where c equal to integration 0 to 1 pyt and dt. Now from here yt equal to, write ft plus 3tc. Okay, now if we put the value of y to integration 0 to 1 t into value of yt is ft plus 3tc and dt, c equal to, okay, this implies c equal to, so this is equal to integration 0 to 1 t ft dt plus integration 3c integration 0 to 1 t square by 2, and this is equal to integration 0 to 1 t ft dt plus 3c and t square by 2, sorry, this is only t square, not t square by 2, and t square dt means t cube by 3, and if we put the limit, then this gives 1 by 3 only, and 3 goes to 3 cancel. Now both sides c are present. Now if c equal to 0, then we get again the trivial solution, and we have to find here the at least one solutions, or it may be this integral equation may be more than one solution, and c vanished from both sides. So c vanished from both sides, there is no present on c, or then no dependent on c, dependency on c. Now we get here integration 0 to 1 t ft dt, this is equal to 0. Now choose the options. From the options, if we take f as option 1, if this satisfies, then we say that the integral equation has at least one solution. So for option 1, integration 0 to 1 t into ft means this is t square minus half dt, this is equal to t square means tq, so tq means t to the power 4 by 4 minus half t means half t square by 4. Now if we put the limit from 0 to 1 t square by 2, then this is equal to 0. If we just put the values of integration, then this satisfied, that is this is the correct option. Now integration 0 to 1 for option 2, integration 0 to 1 t ft, if we put e to the power t dt, then this value never 0, you can easily find, okay, by putting or the by using the integration, you can see this value is never 0 because e to the power t is present here. Now for option c, if we take ft equal to this, then integration 0 to 1 t into 2 minus 3t into dt, this is equal to 2t, integration 2t means 2 into t square by 2 means only t square, and 3t square means minus t cube, and if we put the limit 0 to 1, then this is equal to 0. Therefore this is also satisfies, that means option c is also correct one. And for option 4, if we take fx equal to x minus 1, then t into t minus 1 dt, and this is equal to t square means t cube by 3 minus t square by 2, and if we put the limit, then this value not 0, that means this is also the incorrect option. Therefore the correct option are 1 and 3 are the correct option. Okay, the next problem is this one. Let this is also a 4.75 marks question. Okay, so it says that let y be the solution of the Volterra integral equation yx equal to e to the power x plus this one, and then which of the following statements are true. So here we have to find the y of x. Okay, that means you have to solve the problem. So it is given, see, these types of problems, when you have to solution or when you have to find the solutions of these types of problem, then always remember this shortcut tricks, that the solutions are very tricky in that cases. Okay, may be very tricky, so you have to find that trick to solve the problem very easy way. Okay, so see here, if we take e to the power x plus integration 0 to x 1 plus x square by 1 plus t square into yt dt. Now here the value of lambda should be 1, so that means lambda equal to 1. Now if we compare this, here lambda present and lambda value is not given here, that means lambda equal to 1. Now what is the kernel of this integral equation? So kxt equal to 1 plus x square by 1 plus t square. Okay, kxt yt dt, this is the kernel, and we have to find the resolvent kernel in this case to find the solution. So now if this is k1 say, then k2 equal to what? K2 equal to kxz. We all know that kxz into k1 xz into k zt dt. Okay, dt integration 0 to x, I think integration 0 to x, or if we only take this one integration, yeah, if we write just this one, then what happened? So this is equal to k1 means xz means 1 plus x square by 1 plus z square into 1 plus z square by 1 plus t square. Okay, so that means this is equal to 1 plus z square, 1 plus z square cancel out, and this is again the value of k. Now we have the shortcut tricks. If k2 equal to k1, then we have the resolvent kernel kx t lambda, this is equal to k1 xt into e to the power lambda into x minus t. We all know that the shortcut tricks for resolvent kernel. So here the resolvent kernel is what? 1 plus x square by 1 plus t square into the value of lambda here 1 into e to the power x minus t. So this is the resolvent kernel, and when we know the resolvent kernel, we can write the solutions. The solutions yx equal to e to the power x plus integration 0 to x. The resolvent kernel is 1 plus x square by 1 plus t square into e to the power x minus t into ft dt, that is e to the power t into dt. This is the complete solution of this problem. Now we find, or we put the values of x. So this is the solution. Now we just put this value of x and see what is the correct answer of this problem. Now just one second. If we integrate this, then we get again that e to the power x plus 1 e to the power minus t, or no, we can put the value of x. Now y1 equal to what? Y1 equal to, so y1 this is equal to e to the power 1 plus integration 0 to 1 y1 x equal to 1. This is equal to 1 plus 1 means 2 by 1 plus t square into e to the power 1 minus sorry, if we put x equal to 1, then 1 minus t, I think 2 by t square e to the power x minus t. Just again, e to the power x minus t. Oh, this is goes to cancel out. So this is only e to the power x present. So e to the power 1 or e into d t. Okay, so this is equal to e plus 2e tan inverse t into 0 to 1. So this is equal to e plus 2e into tan inverse t. Tan inverse 1 means pi by 4. So this is equal to e into 1 plus pi by 2. Yeah, this is the correct answer. So option 2 is correct for 1 and 2. And for y root 3, the value of y root 3, this is equal to e to the power root 3 plus integration 0 to root 3 1 plus x square means this is 4 by 1 plus t square, x square means root 3 square means 3, and e to the power root 3. So this is equal to e to the power root 3 common, and 1 plus this 4 tan inverse t from 0 to root 3. Okay, from 0 to root 3. So this is equal to e to the power root 3 into 1 plus 4 tan inverse root 3 means what? Pi by 3. 1 plus 4 into pi by 3. So this is equal to 1 plus 4 pi by 3. Answer 4 is the correct one. This is 3 by 4. This is 4 by 3. So here option 4 is correct. So these are the correct option, 2 and 4, and 3 is incorrect. So these are the 3 questions which comes in the last year paper of CSIR-NET December 2023. So hope this session is very helpful for you. Thank you. Visit again, and if this session is helpful for you, then please give a like to this video, share it with your friends, and don't forget to subscribe the channel. Okay, thank you.